Welcome everyone to the June 2021 meeting of the Memphis Astronomical Society. I'm your host, Jeremy Veldman. Got another very informative program for you guys tonight. We've got one of our own, Freddy Diaz, who among other things is an expert on telescope automation, and he's going to be talking to us tonight about plate solving. So if you're into astrophotography or getting your telescope set up for automation, then this is a program you're going to want to pay attention to. But before we get started, a couple of preliminaries. So I'm going to go ahead and share my screen. So first of all, we are the Memphis Astronomical Society. And again, we are a nonprofit public service organization promoting interest in education in astronomy and related sciences. You can find us online. Our website is memphisastro.org. We also have a Facebook group. We're on Twitter, and of course, we're on YouTube. So if you haven't already, please take a minute to subscribe to this YouTube channel. Want to again say a special thanks to our now nearly 2,000 subscribers for sticking with us, and hope you get a lot of value once again on tonight's program. And thank you again for being a part of our community. If you are interested in joining our group, simply go to our website, memphisastro.org. And there are two places you can go to join. You just click on the join button, either on the right side or in the upper right, and it will take you to a separate form. Fill out your details. And again, we'd love to have you as a part of our community. So the membership process is very streamlined now. We don't do it necessarily at every board meeting. We just simply have a Slack channel now that we do this. And we announce, a handful of new members every month. And our community is growing. If you're new to this channel, if you're new to astronomy in general, doesn't matter what level of experience you're at, you want to learn, if you're passionate about the subject, then we would love to have you as a part of our group. So go to our website, memphisastro.org, and click the join button and fill out your details. And we would love to get to know you better and know how we can better serve you as you progress in this hobby. Now, to be added to our email list, you can also go to joinmas.com and enter your name and email address. And again, we send out notices about once a week regarding upcoming events, whether they're meetings like this is our general meeting, or observing sessions or public outreach events. 2021 has been a transition year for us, out of a pandemic, back to normal. We're back to normal now, so there are going to be more events coming up. So if you're local, or even if you're not local and you'd like to be added to our list, just go to joinmas.com, enter your name and email address, and we'll send you notices on upcoming events, as well as other news regarding the Memphis Astronomical Society. Calendar of events, June, summer, and we got another full slate of events coming up this month, of course, weather pending. Tomorrow night, we're scheduled to be at Burton Sugar Farm once again. I will tell you ahead of time that the skies don't look favorable, but we'll continue to keep hope alive, and we will check the weather the day of and give the official go, no-go notification tomorrow afternoon. And if the skies do in fact clear, then we'll be back out there again. And again, we're in June, so astronomical twilight is about as late as it gets in the year as we approach the longest day. So we typically get out there 8:30 to set up. And then about 9:30, 10 o'clock is when it gets dark enough to do some real observing. But tomorrow night, the 5th of June, if it's clear, we will be at Burton Sugar Farm to do public observing, dark sky observing. And we'll be there again next week, again, right after the new moon. That'll be the 12th of June. So if it's not clear tomorrow night, next week it could be clear. So we're planning to be out at Burton's on June the 12th also for dark sky observing. And the following Saturday, the 19th, we have another observing event at Shelby Farms Park. And again, this is in the city, more urban. So we typically go after the brighter objects like the moon and any of the planets or some of the bright, messiers that could be out, anything that we can see. So P5 parking area, it's located right off of Farm Road. If you're coming from Walnut Grove toward Shelby Farms, it's across the visitor center from Hyde Lake. So we were there last month, had a very good observing session. And so if it's clear on the 19th, we're planning to do that again. And then the following Saturday is our next astrophotography group meeting. And we'll talk about that in just a second. And then the Saturday after that, July the 3rd, which is July 4 weekend, you don't have firework plans, come on out. We'll be at Burton Sugar Farm again. So the next 4 Saturdays, next 5 Saturdays, actually, we've got something planned. So yeah, we're starting to open up again and get back to normal. So if you'd like to see what's coming up, go to our website and click on the calendar link, and you can see what events are coming up this particular month. And of course, that begs the question, when are we going to get back to our live in-person meetings? And the plan kind of was to do this next month in July. Our meeting for July will be July the 9th. It's the second Friday in July because of the July 4 weekend. And we were planning to show a documentary film called Luminous, which documents an astronomer in Michigan in his quest to predict a supernova. It's a 90-minute film, and we were looking for venues. We're still looking for venues for this. Long story short, we've decided to postpone that until October. And the reason is, first of all, we got to secure a venue and kind of get our ducks in a row. But really, the bigger picture is, even though COVID is essentially over, it's not 100% over. And we did not have confirmation that any venue that we could potentially show it in would have lifted all the restrictions by that time. So we had a situation where there was possibly some seating restrictions and some other things. So we want to do this right. We want to make sure that things are fully open, that there aren't any, mask mandates or social distancing mandates. Hopefully we can get all that behind us as more and more people get vaccinated and COVID is more and more in the rear view mirror. So long story short, we're going to be virtual for a little while yet. We still don't have the green light at Christian Brothers University to resume our live meetings. So, and I'm not sure that's going to happen anytime soon. If it does, it'll be well into the fall, and it may not be until either late this year or early next year. So for the foreseeable future, we're going to continue to do this, be holding our meetings via Zoom, and shoot for the first Friday in October to show that documentary film Luminous. Hopefully, we're looking at maybe the Pink Palace as a possible site, and maybe 1 or 2 other areas, but that's the plan right now. So status quo as far as our monthly meetings, we're going to continue to do that via Zoom, but all the other public outreach events, whether they're observing sessions or any other type of outreach event that people ask us to do, that's officially open now. So we essentially announced that last month. Well, let me go ahead and reiterate that again. So public observing sessions, whether they're dark skies at Burton's or in town at Shelby Farms or any type of public outreach event, we got clear skies, we got favorable conditions, then as far as I'm concerned, we've got the green light to get out. So that's kind of where things stand right now. So we'll keep you posted and hope for the best as we get into the fall. Now, we've been doing virtual star parties. We had a great one last month, again, on May the 22nd. And I believe we're going to have another one coming up this month. We don't have a date officially announced yet, but it's typically around the time of the full moon. So once that becomes official, we'll go ahead and send notices out regarding this as well. So MAS has been a participant in these events throughout the course of the year. And this, again, is hosted by Vanderbilt University, Dyer Observatory. A couple of us have been participating pretty regularly, looking to get more active in this. So again, until things completely open up, we can do virtual star parties. So keep your eye out for notices regarding this as well. Another Tennessee statewide virtual star party coming up sometime later this month. Okay, with that, I would like to announce a couple of new members that have recently joined our group. And the first one is Clayton Folks. And Clayton is from Covington, Tennessee, I believe. He works in the automotive/military industry, and he found us on Facebook. So he has some general interests in not only astronomy, but astrophotography. So Clayton, welcome to our group. I won't put you on the spot. and ask if you're here tonight, because that's been kind of hit or miss. And we have a long-standing tradition of the people that we announce as new members not actually showing up for the meeting. So if you're here tonight, welcome. And we are happy to have you as a part of our group. And you've broken a long-standing tradition, and we're very proud of that. We always like participation. Laura Wilson Perry is from Memphis, and she is actually a historian, and as she classifies herself, a tinkerer. And she found us online, also Facebook and a Google search. And right now she's just trying to learn how to use her telescope. She's got a Meade 127 millimeter telescope with an equatorial mount, and is interested in chasing down Messier objects. So next time we have an observing session, Laura, feel free to take your telescope out, especially at Shelby Farms or even Burton's. And we would love to help you get more familiar with your telescope. But for now, welcome to our group. Ralph Stone is from Georgia, Toccoa, Georgia, and he found us on YouTube. And he's just beginning with a pair of 25 by 100 binoculars, kind of getting started in astronomy and getting his feet wet and trying to figure out what he likes and doesn't like. I will tell you, binoculars are a great way to start this hobby. You don't necessarily need a telescope right away. I've got a few telescopes. I love them. But what's interesting is the guys that have been doing this for a long time and have experimented with a lot of telescopes, they actually end up back with binoculars because it can be a hassle to drag equipment out to dark sky sites all the time. So there's no substitute for a good pair of handheld binoculars. So you may start there, but you could also finish there as well. So Ralph, greetings. Hope everything's well in Georgia, and welcome to our group. And finally, Mark Holloman, and he is from Lepanto, Arkansas. I believe I said that correct. Lepanto, Arkansas. And once again, he found us via YouTube, and he is interested in learning more about astrophotography. So Mark, welcome. And to our 4 new members, welcome to our group. Just a universal round of applause. Again, I won't put anybody on the spot, but thank you and welcome to our group. And we hope that you continue to get a lot of value out of participating in the Memphis Astronomical Society. Now, when you become a member, you get access to the Meteorite, which of course is our newsletter. We send this out, and this has some great information in it, including minutes from our past board meetings, star charts, sky charts for the month, articles from some of our members, as well as an astrophotography gallery. So check out the Meteorite. Got some good content in it this month, including a write-up on the astrophotography group forum by our very own Rick Honey. So Meteorite is our newsletter, and one of the perks of being a member is you get access to this. So keep an eye out for that. As far as the news, that also we post in the Meteorite. And May has been, another quiet month, more or less. Probably the most exciting thing for me in May was actually seeing Mercury. I don't recall ever seeing it as well in the past as I saw it this past month. So, Mercury is one of the inferior planets. It's only visible low on the horizon because it's so close to the sun. But it was a thrill to see it at Shelby Farms earlier this month. It reached maximum elongation on May the 17th, I believe, which is the highest angle in the sky from where it is relative to the sun. I tried to snag the conjunction last week, but we had cloudy skies. So unfortunately, I missed that. But it was a pretty exciting month if you're into the inferior planets. But other news, it looks like the United States has got company on Mars as China landed its first rover a couple of weeks ago. I believe May the 22nd is the official date. So it's getting interesting now in the space race as well as the exploration of Mars.
Rover wars.
Yeah, rover wars, exactly. So check that out. As far as the official write-up, I won't get into the details right now, but we've got company on the surface of Mars. We got 2 rovers now searching for biosignatures, signs of past life on Mars, and it's an interesting name, China's rover. I will not even attempt to pronounce that because I'm terrible at pronunciations, but I know that it's named after the god of fire. And I'm not sure that you want to name a spacecraft, especially a rover that's attempting to land on Mars of all places, after a god of fire. So the fact that it had a successful touchdown in spite of all that is is quite an achievement. Let me put it that way. So anyway, I guess it'll be about 90 days, and then we'll see where it goes from there. So the race is on to find whatever they're going to find on the surface of Mars. So, okay, June 26th is the next astrophotography group meeting. And of course, this is hosted by Rick Honey. This is his group. And there's some pretty exciting things happening right now with the astrophotography group, as shown here with these two images. So I'm actually going to ask Rick to say a couple of things because I know he wants to comment on what we're doing right now. So Rick, what's going on with the astrophotography group?
Thank you, Jeremy. We have been meeting for a few months now and have gone through several topics. Some we'll revisit. We've done things like electronic focusers, uh, auto guiding, some other odds and ends, and but a lot, not all, but a large portion of what we're doing is based around image processing. Because to get these really nice images, it you basically have to start processing the image um, after you grab all your data files. I hope that you're seeing my computer screen now with this is our website. I want to do a quick shout out to Steve Wright, one of our members, and his daughter Sarah, who did our graphics. They're graphic artists, and they contributed a lot of work in really helping us spice up our website with great graphics here. And that recently got translated into a new header for our Facebook page. So thank you very much, Steve and Sarah. Uh, Back to the Memphis Astrophotography Group, uh, we have, it, at least among this particular group, it seems like most of that our image processing is being done with either tools that can be had for free online or PixInsight, which is not a free tool, but it is a complete suite of image processing tools that seems to cover just about everything relative to astrophotography. And then, of course, there's Photoshop, and there are some other tools, but we seem to have settled on PixInsight that most of us are trying to use. And one of the things that we're going to try to do is kind of like the short course in astronomy, but we're going to be developing a teaching opportunity, a learning opportunity for image processing over the next few months. And we thought to do that, our best approach would be to do some demonstrations and teach in modules. So we wanted to start out with some very good image sets, some data files for good images. And we actually at one point started talking about buying some telescope time, maybe at one of the Southern Hemisphere observatories, and picking a target and buying time and going and collecting those pictures. But that turns out to be really quite expensive. So we backed off that one and found some already gathered data sets. And we're going to start with, we've already got a complete data set for Omega Centauri, which is my favorite object to look at through an eyepiece. And now it's my computer's background, screen background, and everything else. So we have this complete data set ready to work on. We have the Tarantula. This is Tarantula Nebula data set. Some 90 something files of image files, all pre-calibrated, but 7 different filters for for this image set. We have a complete data set for the Sculptor galaxy. I think this is in GC 253. And then we have also got a complete image set for, and I forgot what this was called. This is 6727, and really quite a lot of color in this one in different wavelengths of light. So we have these data sets that the group can use to practice with and work on. We'll be working through these images. Hopefully, as we get done with some of these, we'll come back to the MAS general group and maybe do a presentation on that whole process and show you some of our results and have fun learning. So that's where we're at, and I will stop sharing and give it back to you.
Excellent. Yeah. All good choices, by the way, especially Omega Centauri and the Tarantula Nebula. I believe, well, the Tarantula is only viewable in the southern hemisphere. I think you can see 253. Not sure about the other one, but Omega Centauri, of course, is only visible very low on the horizon, maybe a month or two out of the year. So, yeah, we should have a lot of fun with that. And most of us have either never been to the southern hemisphere, or if we have been, we haven't necessarily had the opportunity to see some of those targets. So yeah, it should be a pretty exciting opportunity. So if you subscribe, if you're a member and you get the meteorite, this past issue of the meteorite, we actually had a picture of Brian Hancock. He's one of our members, and he's traveled to Chile a couple of times. And there's actually a picture of him looking at the Tarantula Nebula. It's an H2 region in the Large Magellanic Cloud, I believe, which is one of our satellite galaxies. So, and those are only viewable in the southern hemisphere. They're not viewable, here. So you got to go south of the equator to actually see those. So, and the Atacama Desert in Chile is one of the driest areas on Earth. So if you get clear skies down there, it's pretty incredible. So that picture was taken about 6 years ago, I think in October of 2015, but it's really a neat shot of really what makes this hobby so much fun. If you ever get a chance to get under dark skies like that in front of a big mirror and just sit and stare at an object, whether it's the Tarantula Nebula or, of course, there's a ton of targets in the northern hemisphere as well. It's really quite a thrill. So, but these are two of the best. Omega Centauri, yeah, I would agree. That would probably be my favorite globular also. And the Tarantula Nebula, typically only viewable in the south. So again, June the 26th, 7 p.m. So mark your calendars. And of course, we'll have the Zoom link for that on our website. So that will be our next astrophotography meeting. And we typically do these around the last Saturday of the month, right around the time of the full moon. So a lot of exciting stuff going on in the astrophotography group meeting. So it'll be fun to see how this progresses. So for everyone tonight, again, I'll have links to these two documents in the description below this video. And that, of course, is our June sky chart and membership application. Now you can go to our website, click on the join button, give us your details that way. That's probably the quickest way to fill out a membership application. But you can also do it by hand if you would like, and email it back to us at info@memphisastro.org. So probably going to the website is probably the best way to do it. Just click join on memphisastro.org, or you can download this document. All the fields are pre-filled, and then email it back to us. And again, we'd love to have you as a member if you're interested in getting more involved in our community. So with that, I will transition into our main program tonight. And I did meditate a little bit and try to figure out how can I make the introduction more dramatic and more, more impactful. So how do you make plate solving sexy? And the more I meditated on it, I could not find a way to do that. So I thought the best thing to do was just keep it simple and publish what's in the meteorite with an updated version of our logo by, again, Mr. Wright, our Steve Wright. So that is it. Now, I will tell you that Freddy has helped me a lot with my telescopes over the years. And anytime I have one with a go-to mount or anything technical that is not just a knob that you swing by hand, Freddy has been invaluable and instrumental in helping me. And we actually shot an episode of Telescope Tips a few years ago on solar observing. And Freddy goes into details about his setup for viewing the sun, and then also being able to do telescope observing right from his kitchen table if he wants to. So he's really put the goods together when it comes to telescope automation. So Freddy has been invaluable to me. He's one of those guys you need to have in your local area if you're going to get into, you know, the not necessarily clock drive, but anything with a go-to mount where you know, you have electronics that need to be tweaked or adjusted from time to time. So, but this is an invaluable topic, plate solving. So anytime you're setting up your apparatus to do any kind of tracking, especially for astrophotography, you know, this is something you need to become proficient at. So with that, I will go ahead and turn the meeting over to Freddy. And Freddy, take it away.
Thank you, Jeremy. Let me set my presentation and see if I can share it. It will be this. Okay, and then we push this button. Uh-oh. Bear with me. Share. Okay. What? Man. Let me see. Let me minimize this. I'm sorry.
No worries, Freddy.
It's not taking. Oh, okay. Now I will switch. And now there we are. Do you see it?
Yes, we got
Okay. I'm sorry for the delay, but I have 3 monitors, and the presentation didn't want to run on the monitor I wanted. That is the one that is in front. So when I see my slides, I can see you. You can see me looking at you. Okay. Well, let's start with an introduction. We have 2 scenes. We are in what is a cold winter night in the country. Someone set up his new telescope, Dobsonian, and points it to the sky towards a fuzzy thing that he sees with the naked eye. He doesn't know how to identify it. He's a newbie, but he wants to know how to get to the same spot next time. He managed to capture an image of the object with his cell phone. And the second scene is an amateur photographer wants to take a quick look before the clouds roll in, of course, at a galaxy with a new supernova, and if possible, get an image. He quickly aligns his scope, hits the go-to button, and his target is not there. Bummer. Been there, done that. Well, these 2 situations have a common answer: plate solving. So what is plate solving? Well, I went to the technical one and to the Wikipedia one. And on cctheware.com, plate solving is a technique that measures precisely where the telescope is pointing by taking a CCD image and then using various parent matching techniques, matches the star in the image to a given star catalog. Interesting. And Wikipedia says just a technique used in astronomy and applied to celestial images. Solving an image is finding a match between the image, star, and a catalog. Sounds good. What can be achieved with this? Well, according to Wikipedia again, we can calculate the celestial coordinates of any object in the image and synchronize the telescope and the mount to a satellite position to the center of the image taken. So you can exactly know where your telescope is pointed, and you can know how much you have to move it to find a specific object in the sky. How does it work? Well, In order to do this, I went to a site called astrometry.net. That is the source of information and experimentation on my own. I deeply went into this. Astrometry.net is a free site that allows you to plate solving any astronomical image you have. I tested with my own. I first tried to take an image of my images, and it didn't work very well until I decided to use the real scale images, and it worked fine. So the percentage of success was about 100% in my case, okay? But well, we will see how this works. And for this, there is on the site astrometry.net, there is this presentation that I recommend that you, if you have the time, read. I put the link down on the bottom in white. Is the it's making the searchable. It's a fast geometry hashing for automatic astrometry. Sounds pretty fancy. It is, but it's a very good presentation that helped me understand how this works. Okay, basically, normally when I find something, I want to understand how it works first. Then if I have a problem, I can attack it by knowing what is going on and what is the process through it. When I was trying to make my images, photos of my images work, I didn't have a complete understanding of what was going on, and it delayed my studies on this. Okay, so I recommend you, if you have the time, to go through these. The math gets a little complicated, especially for me that I'm just an engineer, but it's interesting. Okay. Well, plate solving. In the past, what was that? Well, plate solving was done manually by accurately measuring photographic glass plates when they were taken with an astrograph telescope with the plates you had after your imaging. So you will have two pieces of glass and you will match, rotate them together. Of course, they have to be on the same scale, and you will find objects that way. But it had no purpose other than find the information after the fact that you took the images. Okay, what happens in the present? We have computer algorithms that associate star positions in the image and group them, and then calculate a hash of the associated stars with the hash from non-associated stars from a catalog. Then when you find that hash, you can match one with the other and can get to a solution of your algorithm finding the object you need. So in this case, I'm talking about the website version of astrometry.net. On this side, you can upload an image, and after some processing, it may take 5 to 10 minutes, depending on the complexity of the image, you will have your object identified. So the challenges when they started working on this are the following. There are many types of images: color, black and white, short exposure. That means they have too little stars. Overexposed, too many stars, too much noise. There are different formats. You can upload GIF, JPEG, PNG, TIFF files, and feeds. So they process all these kinds of type of files and give you the answer. The other thing I may have on this, the star may have extra star, hot pixels. Okay, reflection of lens, a plane that passed in front of your camera and you took just that flash of light and it created a star on your image. Okay, all those things affect the capability of this software, and the software has to be invulnerable to this. The image might have fewer stars. Maybe it's perfectly exposed, but then you have a dark pixel, or you have a bone of dust in the lens that will darken some stars, and then you will not see them. The image may be rotated. If you rotate the camera, the image changes completely, and they should be able to be able to rotate the image and flip it in the way that it matches with the chart that you have. You can, if you are taking the images through a Smith-Cassegrain, the images are upside down and flip horizontally. If you are taking them through on a Smith-Cassegrain through a diagonal conversion, then it will be flip horizontally, but it will be correctly upside down, okay? The scale may be unknown. You don't have to put anything about the image scale. It will detect that based on the calculation they will do. How they do is, well, they created what they call an inverted index, defining a set of features for any particular view of the scale based on star catalogs. When a new image is tested, the inverted index is used to check which view of the image exhibits the same feature value as the index. And I will tell you in a second how is that done. Here the things become complicated with the math, okay? And even when I tried to understand it, it didn't work very good. I can not explain exactly the math because it implies several 4-dimensional calculations between a sphere and a plane, okay? So what they did is they take 4 stars, okay, and choose what they call a quad. A quad is a figure that may be, in this case, like a rhomboid figure, but it can be a square or it can be another figure with 4 points, as long as C and D are on the circle defined by A and B. Did you follow me on that? I hope so. So they computed codes for those nearby quadruples of stars. So they take a sky map and then start selecting quads of all the stars, okay? And C and D will be inside that circle that A and B create. So what catalogs they use? Well, they have 2 catalogs. They use the USNOB, that is on an all sky catalog compiled from a scan of all places. Contains 10 to the power of 9 objects, both stars and galaxies. This is a very complex catalog, okay? And then you have the Tycho 2, that is a subset of the 2.5 millions of the brightest stars. So the Tycho 2 is used for the wide angle images. And the other catalog that I mentioned before is used for the very close field of view images. Well, they mix and cut them in a spatial uniform set of the 150 million brightest stars and galaxies. The final index file contains 144 million stars with 6 quads by star, 205 million quads. And that is for an area of between 4 and 5 arc-minutes. So it's a huge file. And looking through all the indices on that file takes a lot of time. So what they do? As I said, the files are large and long to process. To overcome the large file size, they call a method called hierarchical equal area isolatitude pixelization of a 2-sphere, for short, HILPix. What this does is take the sphere and cut in small areas, okay? And then they create the indexes for those areas slightly overlapping one with the other in such a way that if you have 2 areas, they will overlap and you will see all the stars in those 2 areas. One of the advantages of these methods is that if the user has an idea of where the object is located in the system can start looking at the areas where they're supposed to be and will make the search shorter. And this is the heat pixels for anyone, for n side 1, that means 12 divisions. This is supposed to be your sphere, and then is moved to a plane, and then divided in 12 pieces. So if you know that your object is on 200 out 200 degrees right ascension and minus 50 degrees declination, you will see that the hill peaks number 10 will be the one that you have to set your start of calculations. So how they create the INVEX index? Well, they take a segment of that hill peaks and start making the quads. You see, 1, 2, 3, 4 stars, and the 3 of the stars or 2 of the stars are inside the circle that the 2 biggest are. If you go to the image on the right, you will see that now that a hill peaks, a small area of that hill peaks has all the quads belonging to that area. As you see, there are a lot per area or per hill peaks. So when an image is tested, the algorithms check for many candidate quads match the image. So they take the image and they calculate quads and see if the quads match with that index. Okay. The image is scaled if needed, rotated, and the possible answer is overlaid on the original catalog. The hash code provides a list of candidates. If the list has no candidate, the search fails and another index is used. When I was doing my first experiments on these, I found that after an amount of indexes, it will say no solution. And by example, last night when I was testing my new plate solving system, I couldn't make the system resolve or solve any of the images I was taking. And I will tell you why later. Okay, simple enough? I know it's not, and I had a hard time understanding how it works. This doesn't disqualify us for using plate solving because it works, okay? So how do we use? Well, the research from these professors and mathematics people, David Holt and Justin Lang and their team was made public to the site astrometry.net. So they figured out how to make it work and make it public. Nice. And this is a capture of the website astrometry.net where you see instructions, how you can upload images. If you want to use the web version, you go to nova.astrometry.net, and there you will have a web page where you can upload your image and it will start processing it. If you can use Flickr too. You can upload to Flickr and submit them to the astrometry group or have them solved. I haven't tested that because it was complicated enough, so I just left that way. Okay. You can also download and build your own software in your local Linux or Mac box. You can also compile your Linux file and run in Windows using a software called Sigwin that will allow you to emulate a Unix box inside Windows. So this is, if you go to nova.astrometry.net, you go to the upload file, you select the choose file button, go on your directory, click upload, and a few minutes later, it will tell you what happened. How do we know that? Okay. So let's go back to our friend that took the picture with her cell phone. I don't know if you can see it. It's below below of the center of the screen. You see like 6 stars. Well, that's what he took. Okay. In my other monitor, you can see the stars, but here I can't. But with those 6 stars, he punched that onto astrometry.net, and what happened after 5-6 minutes after that? You cannot see it, okay? But the software can identify the stars on the object, and there it is. He took a picture. If you see, there is a big circle that defines the area of the image, And then you see that it says Orion Nebula M42 and a bunch of other objects in that image, okay? Astrometry.net also gives you a map of where your image is pointing in the sky, and also gives you the calibration where your scope is pointed at the time. And if you see on the top, it says submitted by Freddy Diaz. That is the name of the image, the job, and the status that it was successful. Okay, and it tells you the center of the image, where it's pointing there. Right ascension, 5 hours, 34 minutes. Declination, -5 degrees, 20 seconds, 12 minutes, 43 seconds. So he found it. And I just manipulated the image a little bit, and he found exactly the exact same image, okay? So even when you cannot see what was there, the software was able to identify the stars, match them, and give you this, the center of the image pointed to where it was. The software takes this, what I have shown you here is a web version, but there are another flavors of it, okay? I will show you a list that is a little bit outdated, but is there, okay? The first on the top that doesn't say proprietary are free to use. And in my case, I use Astro Tortilla. That is an application that interacts with your camera and your planetarium software. So identify with the tree. So you go on your planetarium, select an object, send that information to Astro Tortilla. Astro Tortilla orders the camera to take an image and analyzes the image, and then sends the command to the telescope to center the object if it's not centered. Okay. You see that we have peaks inside here, plate solve, pinpoint, and here is not a new system, the new system from other companies. This is a little bit outdated because it's on Wikipedia. Okay, so the software that is available, Astro Tortilla, as I told you, under GPL3 license, and that is the link to download it. Once you download Astro Tortilla, I can give you a link that will show you exactly how to install it for Windows PCs, and how to download the indexes for based on your shortest field of view and your highest field of view based on the telescope and cameras you have. Once you do that, you can integrate that with your application. It may be Sky Charts or any other planetarium software you have, and it will work. There is also a new kit in town. Well, it has been right in town for about two years. It's the ASR Pro. It's a camera control. They call it a camera controller. It's a very small computer, Raspberry Pi P2, that this company has developed to provide pole alignment, auto guiding, and plate solving for telescope pointing. So let's see our fellow astronomer. He took an image and of what his telescope had at the moment, but his GoTo was not good. So he took the image, punched that onto astrometry.net, uploaded the camera, and the results are here. They see his image. He was pointing to the Hercules Globular Cluster, okay? And here's the calibration. He is located, he's pointing at 16 hours, 40 minutes, 54 degrees, 40 minutes, 54 seconds, and 36 degrees, 38, 8 seconds. So he was almost there, but his telescope was not really pointing there. But based on that, he punched in Astro Tortilla And what happens? Astro Tortilla calculates and will move the telescope approximately 50 arc seconds. So it will center the image. He will make a subtraction from the positions and will move the telescope, okay? So the target is centered and bigger to be image observed even in light polluted skies. The advantage of this, once you have polar aligned your scope, like in Shelby Farms, with this, you can point to any dark sky object and it will find it. It will center it because it will find some stars and will do the plate solving. And this is the image of M13. This image was not taken with the new equipment. It was taken a long time ago, about 2 years ago in French camp. But the idea was that what I did is I just cropped the image from the closer to the right, and those were the stars that it identified. So I said, fully automatic telescope. Yes, it can be done. If you do a Google search for auto-aligned telescope plate solving, it returns 212,000 results. So of course you can. So what are the commercial products at range price that we can say for an amateur astronomer? Well, Celestron has one that is called StarSense. As you see, it's a camera that mounts on the telescope, and it comes with a new hand controller that interacts with the camera and commands the telescope to do plate solving. I haven't tested it. I know that a friend of mine has one. It works okay when it works. I cannot say anymore. That's what he told me. And here is the ASR Pro. That is a small box. It has polar alignment, go-to with plate solving, and synchronization of the scope and total camera control. The other commercial brand, Mead, has a solution that is called the Starlock. And if you see, it combines guiding with a long telescope and plate solving with a small camera that is on top of it. One caveat is it must be purchased with a telescope. It's not an individual accessory. You have to buy a telescope, buy one of the big models for $300, and then you can ask for the Starlock added to the price. I don't know how much it costs. And Software Big is the most expensive solution. It's modular and has a plate solving solution. It's a small name, Image Link. I don't have more details. That is what I found. But if you have Image Link, you will be able to do plate solving on the SkyX. Conclusion. Plate solving can be helpful tool for calibrating our equipment and finding dim objects in polluted sky. Also can be used for polar aligned telescope on equatorial mounts. Take an image of Polaris, or where Polaris is, rotate your mount, and the alignment routine can calculate the total axis of your scope, suggesting it moving to the correct position. A precise polar alignment can be achieved much more faster than the drift method. And I can tell you, I used the plate solving routine that one of the programs for capturing webcams called SharkCap. It uses plate solving, and you can polar align the telescope in 2 or 3 minutes to less than 5 seconds of arc precision. That for imaging can give you maybe 3 minutes, 4 minutes of unguided exposures. Here are the reference. They are very small. If you want them, I can provide them to you on an email if you want. And I want to thank Bill Wilson for his help. And thank you.
Thank you very much, Freddie. Excellent presentation. So we'll open it up now. Everybody, round of applause. Anybody has any questions, we'll go ahead and open it up now. I'm hearing it. Kind of kick things off. Go ahead. Question?
Okay. I appreciate Mr. Freddy's presentation very much.
Thank you very much. So,
Thank you.
Freddy, ASI Air and Raspberry Pi. I mean, I've heard rave reviews. Some of us are using it. I know Rick uses it as well. So, is that a comprehensive plate solving solution? And if not, why not?
Well, it has its caveat, as I told you. My C8 with the Canon camera cannot resolve. Okay, I discovered it last night, and the issue is that they don't have put enough indices there on the memory of the ASR Pro, so they will have to change their software to add more indexes, and it will work with the C8. But it will for sure work with any other telescope that is not more than 1,000 mm focal length.
It works on my C925 quite well.
What camera are you using?
See, 2600 and a 294.
Okay, those are big chips.
Yeah, big chips.
Yes, those are big chips. That's the reason why. Basically, the camera will give you a relation. There is a relation between the focal length of the telescope and the image on the camera.
That's the fourth thirds
The
ordination.
bigger the focal length, the wider the image will be, and the shorter the focal length will be on the image. So you need more indexes to be able to resolve that.
What has surprised me positively is I've got a lot of light polluted skies, and sometimes I'm seeing very few stars, and it's still succeeding at solving.
Yes.
Very impressive.
Wow.
I bought an ASI camera back before Christmas, and I bought the ASI Air Pro to control the camera, and it also did telescope control, and so I thought, well, okay, I got that hooked up. I had no idea it would do plate solving. I really wasn't into it for that, but when I used it to go find the first object that I was looking for, and I knew I'd done a not so good polar alignment that night, and it moved to that object, and then it said, wait a minute, the object's not in the center of the field of view. I had no idea what it was doing, and after a few minutes it corrected, moved to it, and centered the object in the field of view. And that's when I realized that it was built into the ASI Air Pro, the plate solving routines, and it's used to center the telescope. It controls automatically. I am tickled to death with that. Now, with that said, you know, I'm using ASI Air cameras. ASI cameras and ASCOM telescope control, but it's the most compact integrated solution for doing everything that I've ever seen. I'm carrying an absolute minimum amount of equipment to the field to go do this stuff now. The telescope, the camera, the mount, this little computer that sits on top of the telescope, and my iPad, and not a lot of other computers or anything else. And
It changes the filter wheel.
Yeah.
Yes.
It controls the scope. It does everything. It's very inexpensive.
I've got
what you didn't tell, Rick, is that the processors that they use on those ASR are the processors that behave bad in the factory. So they are now grounded to work as hard as they can forever inside the ASR Pro. Well, nobody got it.
I'm not sure I get what you're saying.
Well, the processor was grounded to work hard for the rest of his lives, because on those ASR Pro, the processor is working hard. That's the reason why it gets really, really hot.
Okay.
The only negative I found on since the Wi-Fi antenna is inside the now metal box, it gets almost zero Wi-Fi coverage.
Yes.
And that's why this is stuck on the outside of my assembly. This is a little Wi-Fi repeater.
There is also a solution. I have seen several on the internet already. There is a spot when you can drill and you can put a connector for an external antenna, and you have to solder the connector inside the board. It's easy. And then that way you can have an external antenna. It's not hard, but you have to disassemble it and probably will void the warranty.
Oh. It costs less than a lens, so it's
Yeah.
The router is $39. The router that Rick has.
Yeah.
And I have another router that is 12 volts. It's not as small as that, but it's a Cisco router and it has very good and with very good coverage. So I can be in the kitchen. I can see the telescope and in the driveway, and I can manage it from my tablet in the kitchen.
I ran 100-foot.
Cozy.
I ran 100-foot Ethernet cable to it, so I get it's faster than any of the other.
And I honestly, I have a solution that, as Jeremy said, I made a small box. It's a just case that I open, and it has a power supply. It has 2 USB hubs. It has a thin client that controls everything. And Astro Tortilla runs there, and I can do plate solving. But last night when I finished with the ASR Pro, I just unplugged the battery, put the battery inside, roll the cables around the mount, roll the mount in, and I was done. And the chair. And that's it. No more things to disconnect. So there is an advantage there. By the way, I have no dependency from ASI at all.
But you have to have ASI everything, like all the cameras have to be ASI, correct?
Yes, that is one of the things that I didn't like. I don't like closed architectures. One of the reasons I don't like iMacs or Macs or Apple at all, and is the fact that it's very closed.
Yeah.
However, if you want to experiment, there is a solution that uses the same Raspberry Pi 2, and there is a bunch of software that can emulate what the ASR Pro does. And of course, that one, you can use other cameras and other focuser because it uses ASCOM and Indy. I can send you the information if you want to. But you need time for that, and we don't have that.
Yeah.
Freddy, how often are you upgrading a software?
It's automatic. When I bought it, I mean, plug in, it immediately connected to the internet. Say, hey, there is a new software version for that. And it will download it and connect it. That's it. If you don't connect to the internet with it, it will work with that software forever, as long as, okay. I think that the new version that my equipment downloaded has multi-star guiding. I select one star and it immediately selects 6 more around the image.
You're talking about the ASI Air?
Yes.
Yeah, it does. And I did with the bad polar alignment, I was doing 16-minute exposures the last time I was out, and still had essentially perfectly round stars with multi-star guiding, auto guiding.
Yeah, we were having fun at Burton's last month. Our impromptu observing session, I forget the exact date, but it was a Thursday night, I think. And you bagged several of them, Rick, including the usual suspects, M13, and I think we got Ring Nebula. That's the last one we finished off. What were some of the other ones you got?
Let me double check.
I tell you, and you failed to mention one critical piece of equipment in addition to the 4 or 5 that you mentioned, and that, of course, is your music stand. There's something incredibly I don't know. It's almost like, so you got the telescope, you got the tarp, you've got everything, and you've got a music stand with your iPad on top of it. It's almost like an evil opera conductor sitting there manipulating this equipment. Yeah, there it is. So
So I
key
take
piece
this
of
with
equipment.
me and just set my iPad on it.
Oh.
I mean, that's brilliant right there.
Yep.
I sit back in
Nice.
my chair and twiddle.
There you go. There's your portable astrophotography orchestra, or whatever you want to call it. So
But my wife is actually even saying that now that we can just set all this up and then sit in the comfort of the truck and do all this from the driver's seat, she might even go observing with me sometime.
yeah, anything to make it easier, right? So I think you got M101 also, Pinwheel Galaxy. That's another one that kind of stood out.
I remember that.
I posted those on our Facebook page. Let me put them up real quick.
But Rick, your setup was essentially quick and dirty as far as polar alignment, and you just let the ASI Air Pro do the rest, correct?
Well, and I even let the ASI Air do the polar alignment. It runs all that. I just was struggling to get it right that night. It got close, and I finally just accepted where it was. But and the other thing that I had added to my setup was a light pollution filter, and that's why I was using the longer exposures than I had prior. I just wanted to see how long it would go. Where did those go?
So Scott, what size is your guide scope?
I have a 200 millimeter guide scope.
Right now, I repurposed the finder scope on the Celestron 4A, which is 162, I believe. And that worked. I tried to use off-axis guiding, and I found it very difficult to use. And then I have on order the SV Boni, which is a 60 millimeter with an f4, so it should be 240, which would be a slightly better match if it's any good. That comes tomorrow
Okay.
with a 290 as the 290mm mini as the guide camera.
So this is M57, and that was about a 15-minute exposure. And I wasn't doing that. I didn't do anything. I just told it to go to that and start the exposure. And I sit back and listen to some music for a while, and then bam, this is what pops up on the screen.
Is that a single exposure, Rick?
Yes.
Wow.
Yeah.
I
wait.
did the same.
Did I just hear somebody say they have new equipment coming tomorrow?
Yeah.
Jeremy,
I guarantee.
Jeremy, you may as well call tomorrow night off.
That's right.
Hey, it's been total. I've got my 925 that came 4 weeks ago. I think we've had 2 nights with partially clear skies. Texas has not been happy. It's going to be another week before we get anything good.
Yeah. M82.
Yeah. It's M13 and 101.
Yep. Pretty good structure there. I mean, you can see details. The surface brightness of this one is not very high. So what is the, how many this is just one exposure, right?
One exposure, again, 16 minutes roughly.
What class Bortle is that?
4
Yeah, 4.
roughly. And the stars are a little egg shaped, but not bad.
Rick, how'd you focus that? Did you autofocus?
Autofocus. Yeah, I got the ASI focuser. I understand Freddy's issue with closed architecture, but when it's all their stuff, they maximize what can be done with it for me. So I spend as much of my time doing other things other than figuring out how to solve these problems.
Can you manually focus with the ASI here? I assume that.
Absolutely.
Yeah.
Yeah.
Just for the mask.
The software allows you to go in and make all kinds of adjustments. The other beauty is so far, and you can run other equipment with it. It doesn't have to be ASI equipment. You can drive other cameras. There's instructions for how to do all that. With ASI equipment though, it detects which camera you have hooked up to it. It adjusts everything accordingly. It auto calculates the focal length of the telescope. It auto focuses. It auto plate saws. I leave the focusing mask at home. I don't touch it anymore. I took the Orion. What was that little camera I had on my mount for doing polar alignments? You know, that's going in the box of stuff for sale because I don't need it anymore. It's just been fun to have all this just ready to go and set up and work.
Yeah, it kind of makes you a minimalist especially when you're traveling, which is essential. So the days of connecting a laptop and then driving your rig from a laptop I wouldn't say they're over, but certainly this is a better alternative.
Now, this is essentially mounts on top of my telescope. It's the guide scope, the ASI air, the extra external Wi-Fi thing, and I've got a cable set that straps to this one wire loom of cables that run down to the power supply that runs this, and the serial cable to control my telescope. And what else is in there? That's it. Then the cable comes out of here, goes to my camera and to my focuser. I don't have a filter wheel because I use color cameras. Again, my primary purpose was never really to do astroimaging so much. I want to be able to use this for public demonstrations. So I want to be able to show people color pictures captured directly off the telescope in one shot on a big screen, or use a projector screen or whatever. So
Yeah, that will be exciting to be able to do that. See what you can see during a public demonstration. So we have yet to have favorable conditions for something like that. All right, a lot of comments coming in, all positive. Thank you, Freddie. Thank you. Thank you for sharing your wealth of knowledge. And anyone using astrometry.net for color calibration, I believe that's a question. So, anybody have a comment on that?
You can, because if you go to astrometry.net and you do a search for an object, you will find a whole bunch of images from that object that with all the submissions with people that had done that. So you can find a bunch of images and decide which one is the one you want based on the colors or the way they are represented there. So if you like to have more red, well, you can use the image of, you know.
Yeah. And also, oh, sorry, go ahead.
Yeah, PixInsight does that. It has a module where it goes out and checks other people's photography, and if you're a little off, it'll correct your color a little bit.
Is that photometric color calibration?
It's some external module.
No. Okay. I have to Google that.
Yeah. And Freddie, for the benefit of of our listeners, can you clarify the hash? That was
Hash is a way of reducing information.
okay.
The
The
most
subset?
the most common use of hash is, by example, when you are using security protocols. Instead of using a big number, you use a hash that is a mathematical function of the big number, but it cannot be reproduced any other way. Okay, in this case, the hash is a reduction of the indexes in a way that is unique and is smaller for each object.
I see.
In this
Easy way.
case, for each quad.
It's an easy way to sort some big objects that are not structured. Also a way of determining that something's the identical one. If I take a piece of code and I hash it, I've got many, many megabytes and I bring it down to a single number. If I then modify that code by changing one bit, the hash will be very different. And so you compare a single number with another number and you know that it is different. It means it's been modified. And that's so it's used a lot in security.
Oh, damn.
We can mute it. We can edit that part out. Any other questions? Or as one of my professors would say, any other questions, comments, cussing or discussing?
I have one comment. It just so happened I was looking for something to help me find objects in a sky with a lot of light pollution. And it looks like, thanks to Mr. Freddy, I've got everything I need to help me out there. And I really appreciate that. And gentlemen, thank you so much for the good work you do on your presentations and bringing this expertise to the virtual meeting. I really appreciate that. I'm in Virginia, so it's not like I can pop over to Tennessee often to see you in person, even though I'd like to.
Absolutely. Michael, welcome again. Thanks for joining the call. Hope everything is well in Virginia. And yeah, this is I guess one of the unintended consequences, or one of the upsides of being virtual the last 14 months or so, is we get a chance to expand our reach a little bit. So happy to.
Let me say that we intend to continue with a virtual component as we go back to in-person meetings. I haven't figured out exactly how we're going to do that yet, but we would certainly like to be able to do a combination where not just the local Memphis people can attend, but others that are not local to Memphis can attend and participate.
Yeah.
Well, thank you for that, sir. And I'd appreciate it if you could continue providing this service.
Looking forward to giving it a shot.
As one of my favorite rock stars said after they reunited, we're a band and we're going to continue.
Awesome.
Any other questions or comments?
Can I put in a somewhat off-topic question? As a new owner of a nicer telescope, I had my first time outside where it did get dewy in the morning and very wet. And I've been worrying about what happens if it's out and gets wet. How water resistant, safe from damage, are good telescopes?
I've never seen one damaged by it.
By humidity, dew?
Well, humidity, or you set up a 4-hour session and in the middle of the night, weather changes without knowing about it and there's a little bit of a rainstorm.
Well, you leave it quiet where it is and wait for it to dry in the sun. That's it.
Okay.
I've never seen anything get damaged. It's not waterproof. A torrential downpour might get water in places that shouldn't have it, but I've had dew. I've had everything I own soaked at the end of an observing session, and you dry it off, let it dry the next day, everything's fine. I've never had an issue. Most of the steel components, your drive axes, all that are not mild steel anyway. They're typically stainless, are coated in some way. So
Aluminum.
yeah.
One thing that you can get is telegizmos covers.
Yep, I got one.
Okay, if it's already, you just cover it and tie it well, and that's it.
If I'm sleeping, that doesn't work, but it works during the day.
Yes, well, you know, let me tell you, the first time I went to French camp, I bought an observing tent. That is a tent where you remove the top of it. Rick knows that. You remove the top of it and you can observe, and then you can put your tent back and you will have cover for the night. That worked fine until we had a torrential rain in French camp and the roof just collapsed. And when I opened the zipper, there was about 20 inches of water inside the tent. Everything was floating, my clothes, everything. The scope was drenched. Nothing happened. The only problem was me, that I didn't have where to sleep that night. So I ended up being a refugee on Rick Honey's tent. So, nah, don't worry about that.
If you want to watch a highly entertaining video and may lend some more insight, check out the Okie-Tex Star Party from 2018. I've included the link here from Deep Sky Dude, his YouTube channel. And it was basically a complete rain out, including some highly entertaining footage of exactly what you're talking about. Telescopes exposed in the elements for the better part of a week in torrential downpour. In fact, that year was called Sokie-Tex, not Okie-Tex. So yeah, there'll probably be some clips in there that will be pretty revealing as far as what these telescopes can endure in the way of rain and elements. So I included the link here in the chat. All right. Anybody have any other comments or questions as we're wrapping up here?
There's a shout out that
Very
the
much, Freddy.
Texas Star Party there's gonna be the virtual Texas Star Party is on the 10th through the 12th.
Thank you. Yes, I actually got that on my calendar. It's virtual this year, and it'll be June the 10th. I believe it starts at 8 or 9 o'clock in the evening. So
It's 7 o'clock Central Time on Thursday and 6:30 on Friday and Saturday.
gotcha. So that'll be next week, because today, is it next
Right.
week?
Exactly. It's next Thursday, 6 days from now.
Okay, yeah, because today is the 4th. Yeah, yep, next Thursday, Friday, Saturday. Yeah, they've got a great lineup, including some people work at the McDonald Observatory. There it is, it's Texas Star Party. So yeah, another virtual event that you can attend. Thank you, Scott, for bringing this up. Yeah, this is next week. So if you got a chance to check this out, I think they'll be recorded also. So
TexasStarParty.org.
yep. TexasStarParty.org. So yeah, check that out. I do have that on my calendar. I'm looking forward to checking that out. So getting a little bit of the Texas Memphis connection, which would be great. Be nice to do some more cross collaboration. You guys got some good stuff going on over there. Got some good astronomical societies. In fact, the Houston group, I think they got a pretty sizable membership, if I recall correctly. HAS, Houston Astronomical Society. Yeah. All right, very good. Thank you, Freddie. Thank you, everybody, for your comments. Very informative meeting once again. Let me go ahead and share so we can just go ahead and wrap up here.
Good to see you, Neil.
Neil, good to see you. Yeah, welcome. Thanks for attending again.
Yeah, thank you. Here from 7,200 feet out here in Santa Fe, New Mexico.
Oh, man.
I think the monsoons have hit us though here.
Well, that's what happens when somebody buys a new piece of telescope equipment, as the cloud gods take revenge.
Amen.
That's why don't throw your old telescopes away. You need to have something to sacrifice to appease them.
Something
Well, thank
with
you very much. I enjoyed it.
Thank you.
Thanks.
Those old ones with wooden tripods go up pretty quick.
Absolutely.
All right.
Okay, wrapping up here. Again, if you'd like to join our email list, go to joinmas.com, enter your name and email. And again, I'll have links to these two documents below. It's the June sky map as well as our membership application. And you can fill it out and email it back to us at memphisastro.org. And those are our links online for Facebook, YouTube. Again, subscribe to this channel as well as Twitter. And with that, we'll go ahead and wrap up. Our next meeting is going to be, I believe, 5 weeks from today. Again, first Friday is the weekend of the 4th. So we'll skip that one and we'll resume again July the 9th. We'll send out details regarding what that meeting is going to be about and what it's going to entail. Tomorrow night, not looking good, but we'll keep our hope up. The following week, we've also got an observing session scheduled. That's the 12th of June. Hopefully skies will be favorable then. We got something every Saturday for the next 5 weeks, going right up until the 4th of July weekend. So yeah, we're getting back out there and hopefully get some quality observing in one of these days. But with that, I'll go ahead and wrap up. Say thank you again to Freddy and everyone else for attending. And you guys have a great night, and we will see you in 5 weeks.